We can use proxies to implement network address translation. On our networks, we could have a proxy server implementing a network address translation. Here, what we have is computers on our network with private addresses. They cannot communicate across the internet. So we implement a proxy to allow the conversion of private addresses to a public address in this fashion. Computer B puts a packet on the network asking, what is the weather tomorrow from Google? That packet is sent to the proxy. The proxy will process the packet, flag the message, and we know the proxy would remove the address of B and send the message on to Google. Google will reply with the message, the weather tomorrow is -5. We know it's coming from Google. It's addressed back to the proxy. That packet is put back on the network, back to computer B because it is flagged for computer B from there. And you know it's coming from Google going to B. What we have here is in private internal addresses have now been converted to a public address. This is what we call network address translation. Network address translation allows us to preserve the use of IPv4. IPv4 public addresses. The public addresses were starting to run out at the rate at which the IANA had to adopt a strategy, had to come up with this strategy for organizations to share public addresses using a proxy to achieve network address translation. This allows us to limit how public addresses are issued to organizations without the fear of running out of public IP addresses. Network address translation allows us to achieve multiple computers can share a public address. Network address translation also enhances caching because the proxies don't have to get subsequent requests provided it's been requested earlier from the internet. And they also offer, the proxies offer security by protecting, masking the internal addresses from servers on the internet or malicious persons on the internet.